Chapter 2, Section 2, percents greater than 100% and less than 1%. Now, I just said greater than 100%, but yesterday I said that it was impossible for you to give more than 100%, and I double dog dared you to go tell your coach when he said that he wanted 110% to tell him it was mathematically impossible. Did any of you all do that? Cowards. Alright, let's move forward. How can you have percent greater than 100%? Well, that involves growth, and we're going to see what we mean here in just a minute. Content objectives, students will use the 10 by 10 grids to model percents that are greater than 100% and less than 1%, and I'm honestly curious about how we're going to do that. Suggested pacing says this is a 45-minute lesson, so we should knock this out in a single day, and you have no new vocabulary terms, so let's get started. A local restaurant added a new soup to their menu, and their soup sales increased by 175%. But how do you get a number greater than 100%? That's what we're talking about when I said growth. And that'll go ahead and answer the next question here, which says, how might the manager explain the 175% increase in soup sales to his employees? Well, it's like this. You have 100% is a normal day sales. And then you had 75% of the normal day sales that you added to the 100%, and that's your new day sales. So here we're talking about growth. 175% can involve growth. You cannot give 175% of your effort because, it's mathematically impossible. All you as an individual can give is 100%. But the number of touchdowns you score or the number of home runs you hit, there can be growth there, so you can increase your percentages that way. Sometimes a percent can be greater than 100% or less than 1%. To model a percent that's greater than 100% or less than 1%, it might be helpful to understand how to represent percents like 175 with a 10 by 10 grid or ratio. So let's move forward from there. The table shows the total rainfall during April for a certain city for the 3 different years. I'm thinking the total rainfall we've had here this summer has been just unbelievable. It's like it started the first day of summer and never stopped. You can use ratios and scaling to compare values using percents. So you can see we've got 2017, 2018, and 2019. Moving forward from there, in 2018 it rained less than it did in 2017. To compare the rainfall from 2018 to 2017, you would use a ratio of 3 to 4 because you had 3 inches in 18, 4 inches in 17. You could set that up as a part to a whole, which when you compared it to 100%, you would have 75% of the rain fell in 2018 when compared to the rain that fell in 2017. The 100 came because we multiplied the top and bottom 4 by 25. 4 times 25 is 100. 3 times 25 is 75. If the number being compared to 100 is less than 100, then the percent is going to be less than 100. So the 75 was less, the 3 was less than 4, 75 is less than 100, so we have less than 100% of the rain that fell as compared to the previous year. However, in 2019, it rained cats and dogs. You had 5 inches in 2019 compared to the 4 inches in 2017. So now when you look at your part to whole ratio here, 5 to 4, you would take and multiply once again the top and bottom by 5, and that would give you 125 to 100. Now we're looking at a percent growth. So you have 125% the rain fell in 2019 when compared to the rain that fell in 2017. Percents are greater than 100% when the number being compared to 100 is greater than 100. When percent is greater than 100%, the part is greater than the whole. That almost sounds like omniscient or something. The part is greater than the whole. You are more important than your entire team. Select the flashcards to learn about percents greater than 100. So the flipping the first flashcard here, it says 125% means 125 per 100. They've shown it written with a colon, with the word to, and as a fraction, and how you would read it. Meanwhile, if we were to model 125%, that means we would need to use two 10 by 10 grids. The first 10 by 10 grid is solid, it's entirely filled. The second 10 by 10 grid, we have 25 of them filled, representing the additional 25%, 100% plus 25%. That's where your 125% is going to come from. Suppose the rainfall in 2020 is 5 inches. What percent compares the rainfall in 2020 to the rainfall in 2019? How about you pause the recording and work on this? As a little hint, 2020 is 5%, and if we went back here, 2019 is also, not percent, 5 inches. So what would the rainfall comparison be? Pause your recording and solve that. Now we're comparing 2020 to 2019. And when you look at those numbers, 2020 had 5 inches of rain. 2019 also had 5 inches of rain. So what would that equal to be over 100? Well, 5 times what number is 100? 20. So I'm going to do it on the top. 5 times 20 is 100. That means you have 100% of the rain in 2020 that you had in 2019. So what percent is going to be represented by these 10 by 10 grids? You can see you've got two 10 by 10 grids that are entirely filled, and another one that is 1, 2, 3, 4, 5, 6 rows are filled and 3 additional. So what percent is that going to represent? How about you take and pause the recording and see if you can fill in those grids real quick. We have 2 whole grids that are shaded, and we have 63 grids shaded in the third grid. So check our answer, and that part checked. Let's move on to the next slide. So there are how many squares shaded all together? We had 200 plus 63 is going to be 263 grids shaded all together. Move on to the next. The ratio that compares the total number of shaded squares to one whole grid of 100 is 263 to 100, written 3 different ways. Therefore, the percent represented by the 10 by 10 grid is 263%. Check it. Woohoo, we got the right answer. How can you quickly determine the number of shaded squares on the grid without counting every square? Just like I just showed you, where I counted how many rows of fully shaded squares there were and then added the few that lingered on. I used multiplication and addition to get to that answer. Now it's your turn. Pause this recording, solve the problem on your own. I must say this one disappoints me. It's the same answer, 263%. Check your answer. Same thing we just, you think they could have at least given us some new artwork to go with. Lazy. Oh, look, it's a kitten sitting on a scale. At birth, the average kitten weighs 5 ounces. At 3 weeks of age, the average kitten will weigh twice as much as at birth. Write a percent that compares the weight of the Write a percent that compares the kitten's weight at 3 weeks to its weight at birth. Use 10 by 10 grids to model the percent. Well, we know that it weighed 5 ounces at birth, and that it weighed twice as much as 5 is 10 when it was 3 weeks old. If the kitten's weight did not change, what percent would it be compared to his on-change weight at birth, it would be, oops, dang, I did not mean to do that. Let's quit that, cancel. We do not want to do that. What percent would it be? It'd be 100%. But that's not what we're looking for. We're looking for doubling the size of a cat, or at least its weight. So move through the slides. If you have this on your device, pause your recording and try and do it on your own, and then go from there. At 3 weeks of age, the kitten is now going to weigh 10 ounces, twice of its birth weight. Good. Moving forward, you can see you have ratios of 10 to 5 written 3 different ways. Compares the average weight at 3 weeks age to its birth weight. Next, now we can set that up as the 3-week weight compared to the birth weight is a 10 to 5 ratio. Multiply top and bottom by 20. That gives you a 200 to 100 ratio. My bottom number here is 100, so that is a 200% weight of his birth weight. From there, last thing we need to look at, if we were to show that on the 10 by 10 squares, you would have two 10 by 10 squares completely shaded to explain this answer. Now suppose a veterinarian states the kitten's weight increased by 100%. Is this claim correct? Why or why not when talking about the kitten's weight? When is the correct use of 100% and when is it correct to use 200%? Well, technically the veterinarian would be right, because he didn't compare it to what it was. He said that it increased by 200%. That means whatever it was, you take that amount, added another 100% to it, and you got your increase, you got your new cat. You would use 200% when you would say that the cat weighed 200% of his birth weight, when you're comparing one to the other. When you're just saying how much it increased, it's perfectly good to say 100% instead of the 200%. Now it's your turn. Pause the video and solve this one on your own. Check your answers. Did you get it right? At birth, the average baby elephant stands almost 3 feet tall. At 15 years of age, the elephant will be 4 times as tall as it is at birth. Write a percent that compares the elephant's height at 15 years of age compared to its height at birth. Then describe the 10 by 10 grids that would model this percent. Well, the elephant's height at 15 years of age is going to be what is 4 times its height at birth. So we're talking about 400% of its birth height. To do this, we are going to need to shade how many? 4 entire 10 by 10 squares and 0 additional squares. I'm sorry, nope, not 0. I just screwed that one up, and it's going to be a total of 400 squares. Check our answer. Oh, that one's wrong. There's supposed to be 0 squares. Try that again. And yep, that was it. That's what they were looking for. There was no extras. It was only a 400% growth. So it was 4 solid square grids and 0 additional squares. We will stop video 1 here and come back for part 2 in just a minute. Make sure you watch the rest of the video so you can understand everything you need for tonight's homework.